Okay, today we're going to talk about graphing linear equations. And you know what linear means, you know what equations are, and you know how to graph. So this is taking a couple different concepts and putting them together. So put that at the top of your page, graphing linear equations, and put today's date in the top right corner. So what exactly is a linear equation? This is your vocab word for today, linear equation. A linear equation is an equation whose solutions fall on a line on the coordinate plane. So, take a look at that coordinate plane. It would give you an equation whose solutions fall on a line of the coordinate plane. And all the solutions of a particular linear equation fall on that line. So, if I had a linear equation and this was, let's say, y equals 2/3 x minus 1/3. Anytime that we solve for x or y, it would fall right on that line. So that's what a linear equation is. Every single solution would fall on that line. And to find a solution that lies between these 2 points, so let's say we want to find a solution that goes in between here. If we plug in an x, we'll get a y. Like if I were to plug in when x equals 2, y equals 2/3 times 2 minus 1/3. That would be 4/3 minus 1/3, which is 3/3. 3 divided by 3 is 1, right? So when I plugged in x equals 2, right here, x equals 2, I got y equals 1. So I got that solution on that line. That's what makes it a linear equation. And it's obviously straight. And take a look here. As x goes up by 3, right? As x goes up by 3, y goes up by 2. And that's going to stay consistent throughout the entire line. As x goes up by the same thing, y is going to go up by the same thing. That consistency is huge here. Okay? So that makes it linear. So we're going to graph these. So we have y equals 3x minus 4. It says graph each equation and tell whether it is linear. You should be able to know right now whether it's linear. It has no exponents. There's a hint. So we have y equals 3x minus 4. It doesn't give us any x's. So for x's, let's use the easiest things we could imagine. Let's make a table. So we have our x's, y equals 3x minus 4. We have our y's, and then we have x comma y. I'm going to use the easiest things I can imagine for x. -2, -1, 0, 1, and 2. All right, so let's plug these in. So we have 3 times -2 minus 4. That's -6 minus 4. Keep change opposite, should be -10. So that's -2, -10. 3 times -1 is -3 minus 4. And remember, a negative minus a positive, that's like keep change opposite. -3 plus -4, 3 bad guys, 4 bad guys, we get 7 bad guys. Should know that by now, right? You should know how to add and subtract with negatives. 3 times 0 minus 4, that's 0 minus 4, that's -4. So 0 comma -4. 3 times 1 is 3 minus 4 is -1, so that'd be 1, -1. And then 3 times 2 is 6 minus 4 is 2. So 2, 2. It should be going up by the same thing every time, right? -10 and -7, that's plus 3, plus 3, plus 3, plus 3. So it is. Now, we need to graph it, right? So let me minimize this. And let's graph it. Is it going to be perfect? No, but it's exactly what I need. Let's go by 2's on the y's, because that's what I have room for, right? I can go by whatever I want as long as it's consistent. So we'll go by 1's on the x's. So it'd be like -1, -2, -3, 1, 2, 3, 4. And then let's go by 2's here. 2, 4, 6, 8, 10. -2, -4, -6, -8, -10. The reason I did that is because, look, I need a -10 here. So -2, -10, -1, -7, that would fall between -6 and -8. 0, -4, 1, -1, about there, and then 2, 2. So look, we have a nice straight line. That would give us a linear equation, right? No exponents, so we know it's not linear. Or sorry, we know it's linear. And here we have a straight line, so it would be linear. All right, let's try the next one. Graph each equation and tell whether it's linear. So right off the bat, you should know. But let's do this. Let's make a table still. So -1, 0, 1, and 2. Let's just keep it 4. Y equals -x squared. Let's get a y and an x comma y. So here we have -1 squared. That's kind of weird, right? And you have to do the exponents first. -1 times -1 is +1, right? But there's a negative in front of it, so that's going to be a -1. Here, -0 squared. Well, 0 squared is 0, right? And -0. You can't really have a -0, so it's just 0, 0. 1 squared. Remember the parentheses. Negative in front of it. 1 squared is 1, but there's a negative in front of it, so it's a -1. And here, 2 squared is 4, and there's a negative in front of it. The negative's outside the parentheses, right? The reason I put parentheses is because I'm substituting for x, so it's outside of that. So it applies after I do the exponent. So it's going to be -4. All right. So now, let's graph. And here, I only need to go to -1 and -4. Those are my biggest numbers, really, so I don't need to go by 2. So I'm not even going to label it, actually. When you go by 1s, you don't have to say what you're going up by. Just try to make the lines as nice and neat as you can. On line paper, it's not terribly difficult. So, -1, -1, right there. 0, 0, right there. 1, -1 there, and 2, -4 here. So we have that. Now, if you're playing at home, the name of that shape is a parabola. And you know that that is not linear, right? It's not linear because it curves. It's not linear because of the exponent. So, a couple different reasons. Let's try number 3. All right, y equals -3/4 x, or 3x over 4. This one's going to be a little tougher. Let's do 3 points for this one. I know I'm getting smaller here, but these are going to be kind of tough, right? Let me give you a little secret here. It's being divided by 4, right? I want to make my life easier, so I'm going to pick some points that are divisible by 4. I'll show you what I mean in a second. I'm going to pick -4, 0, and 4. So if I plug -4 in here, I'm going to get y equals -3 times -4 over 4. Well, -3 times -4 is 12. Divided by 4 is 3, right? So that would be -4, 3. And let's plug 0 in. -3 times 0 is 0, so 0 over 4 is just 0, right? And -3 times 4 is divided by 4, so that's -12 divided by 4, and you'd get negative 3. So the reason I picked negative 4 and 4 is because I'm dividing by 4. So if I'd multiply by 4, divide by 4, I know that I'm going to end up with a whole number. And I like whole numbers. They're easy. Let's graph that and see what it looks like. See if it's linear. So I need to go down to 4 on the x's. 1, 2, 3, 4. And then to the 3's on the y's. All right. Negative 4, 3, 0, 0, and 4, negative 3. And it should be linear. If I could draw a straight line, it'd be linear. And look, it's negative, right? If you were a business, you'd be losing money. And look, it's negative 3x over 4. All right, this next one's kind of strange. Y equals negative 3. It's strange because you don't see any x's. So here's what it looks like. We're still going to use x's. Stay with me here on this. So I'm going to use the easiest ones I know, right? I'm going to do 5 points here. So I'll use negative 2, negative 1, 0, 1, and 2. So if I don't have x's and I'm trying to plug x's in, I have nowhere to plug it in, right? So it's just going to stay negative 3. So no matter what I put in, it just stays, oops, this should be a negative 3. No matter what I put in, since there's no x's to actually input, it's just going to stay negative 3. So negative 2, negative 3, negative 1, negative 3. Here, 0. Can't plug into x because there is no x. Stays negative 3. So look, all of our outputs, or our entire range, right, all of our outputs together, our entire range is negative 3. So what's that look like when we graph it? And does it make sense that if there's no x's to plug into, I'm just going to get my y back, right? There's no x's to plug in, so of course I'm going to get y equals negative 3. So I need to go to 3. That's it, right? Does that make it difficult? So negative 2, negative 3, negative 1, negative 3, 0, negative 3, 1, negative 3, and 2, negative 3. Look at this. It's a straight line all the way across. Yeah. No matter what x is, right, no matter what x is along this line, y is always going to be negative 3. So that's why we just get this straight line across negative 3. No matter what you plug in, y is always negative 3. So this is linear, right? Just remember, any point on this line is a solution to this equation. Like any point on this line is a solution to negative 3x over 4. Any point on this parabola is a solution, right? Any point on this line is a solution to y equals 3x minus 4. Linear, straight line, right? Non-linear, not a straight line. All right, great job.